Welcome, Aaron. Thank you for sharing your evening with me.
Yeah.
I like things in visuals and charts, so I'm going to share my screen. Okay, so here we have a diagram of a very happy user with their ledger and a laptop. And they have a smart contract wallet provided by Safe. And how the user connects with Safe is through Safe's servers. These in particular are AWS S3 servers. Just focus on this part of the screen where the icons are, and on the right, they're just props I'm about to pull onto our scene. And what the attacker needs to do in order to steal the user's money, in this case, in Bybit's case, was to compromise a targeted dev's laptop. And when you target a dev, it's called social engineering. How did they ultimately compromise this dev? They nerd sniped this dev into downloading a hobby Docker project. It was something like a stock simulation project or something. And through that, essentially that project was malware. The malware basically made it onto the targeted dev's laptop, which then hosted a malicious JavaScript file into Safe servers. So previously, if the user communicated with Safe, Safe would send it a genuine JavaScript file that will then present the information required for the user to assign transactions. But what happened was this JavaScript file was replaced this way by a malicious piece of JavaScript. So Aaron, now that we've agreed this is roughly what happened, I wanted to discuss, like, how is it possible that for an organization like Safe, targeting just one dev allowed you to do such an exploit? It seems like there should have been more protections, or could you say more about what the usual or practical matters are in companies that should have pretty high security?
Yeah, sure. So there's a couple of things that you typically see. So typically when you have a service, a web service, people they might develop on their local machines. They might develop on like a test cluster. Usually you have development machines that are separated from production. And so, we don't know all the pieces in the Safe development stack, but presumably there's ways that some people in the company don't have access to the production systems. They don't have the ability to affect the code that's actually being used for signing transactions and showing transactions to users. But of course, some people do need to have that access because, ultimately somebody is responsible for pushing code onto production. And so, these hackers seem to be pretty informed about the whole situation. They probably knew who had that kind of access, or maybe more people had that kind of access than should. So that's one thing that might have happened here. Somebody may have access to the production system, but then you can have different levels of control beyond that, right? So it might be that someone can just push a code change directly onto that system. Maybe the process is set up so it has to be reviewed by another person, and there's some kind of controls in place.
Right. So in this case, though, like, it was just one, as far as we know, it was one machine.
Right. Yeah, that's my understanding, is that this person's system was compromised, and their AWS login had the ability to push this code into the production systems. Right.
Is that normal, though?
I mean, I think normal depends on the platform, right? So, in many cases, not everyone's developing for this really high security requirement situation, right? So if you're just building an ordinary website, you might not care to put all these different controls in place. But typically, I would say, like, big important platforms, big companies, they'll tend to have multiple layers of security, multiple controls for pushing code to production. But that being said, there are trade-offs there, right? So like if you put too many controls and too many people need to sign off on a change, that can slow your velocity. So not everyone's going to put all those different checks and balances in place because it's going to be development. Yeah.
Okay, so the other thing that was interesting in reading all the reports was, so basically Bybit issued commissioned 2 separate reports by 2 auditor or security firms and published the full extent of these reports. And Safe also commissioned a report but published parts of it. So the attacker basically had gained access to the dev's computer through this piece of malware, which meant that essentially they could capture the password that the dev was putting into the Safe servers. However, they still had to get past multi-factor authentication. They attempted to register their own device, but failed several times. Ultimately, what they resorted to doing was stealing session tokens when the dev was logged in. Is my understanding correct?
Yeah, that sounds about right. And yeah, I think one of the things that made this difficult was that there was definitely some concern made to the security of this account. I think what I read was that the login sessions were meant to last about 12 hours. And so every time the developer wanted to use it, they'd have to re-authenticate every 12 hours. So this kind of shortens the window that the attacker would have if they couldn't log directly onto developer's account as themselves. They would have a limited time window in which they could try to get on the account.
Well, the dev isn't changing his password every 12 hours, right?
Right.
He's basically, the 12-hour lockout would basically require a new 2FA.
Right, exactly. So the developer has their credentials. The attacker maybe knows their password. Doesn't sound like they have their multi-factor authentication. So they need the developer to do something for them to get access to that account. And so they failed at that process, or they failed at logging in themselves using the multi-factor auth. So they went through this different technique of actually stealing the live session from the developer.
Right. Can I dig one level deeper? I have in mind the dev putting in his password, and his computer is basically, completely pwned. So whatever his password is, whether he's typing it in or it's saved, or he's copy pasting it from a password manager, that the malware essentially has access to, correct, right?
Yeah, that's probably what happened.
Then if he's doing a 2FA, in my mind, and I think I'm wrong, if the dev is looking at his phone, say a Google Authenticator or some of the other authenticator apps, and he's putting that number in the computer, the malware could be, if they can see the password, they can also see what's being entered, correct?
Yeah, sure, that's possible. But usually those tokens can only be used once, right? And so even and they're validated for a short period of time, right? But say the attacker was like watching and stole the token right off the computer. Well, I mean, then the developer's going to know about it right away.
You mean steal the 2FA?
Yeah, like if it's an authenticator code and they saw the developer typing it in and they were typing it in on their own system simultaneously, right? And they managed to like log in first. I think that would maybe set off some alarm.
Right.
But I think also it's very probable that the method of multi-factor auth they use could be like a hardware security key, like a YubiKey key or something, and then that's just not possible.
Okay.
Yeah.
That's what I meant by I think I'm wrong. I think this mental image I have is wrong.
Yeah, and actually that's a good reason why it's preferable to use hardware security keys, because they can't be stolen in this regard.
Okay, that is awesome. I didn't expect to get into that, but that is very valuable information. What they actually did, like we mentioned before, was to steal the session token. Is it feasible to detect such theft and usage?
Use of session tokens is like a pretty common thing, right? Like that's typically the way a web browser communicates with a server is you send information to the server, right? And so if you're not sending your username and password and log in with every single request, basically you log in and the server gives you a session token. And then every subsequent request, you provide that. And that's how the server says it recognizes you. And that's kind of like a token that lasts for a short amount of time, maybe a long amount of time. But that gives only your machine the ability to present itself as logged in to the service.
Yes.
Now, the problem is if somebody is able to steal that token, yeah, they could basically behave as you. And I mean, there are ways you could detect it. So the platform, the server on the other end will know things.
Yes.
It will know the IP address of the client. It will know the user agent of the web browser. There's different kind of things that can be used to fingerprint a web browser. So just all the HTTP headers that are provided when you load a web page, right? The server sees all of those. And if you switch web browser or switch computers, switch operating systems, usually there's, if the server wanted to, if it was programmed that way, it could recognize that, hey, this session is like,
being reused.
It's gone to a different system. So it could be detected. If the attacker is very sophisticated, they could figure out, oh, this is the browser that you're using. This is the operating system you're using. They could try to make themselves look like you. They could also do the attack from your computer, right? Like if your computer is already compromised, maybe they don't even need to, they can steal your session token and run the program on your computer, right? And then
while you're like having lunch or something.
Yeah, so then it'd be really hard for you to know. So I don't think there's like a foolproof way that they could detect this. It's kind of a way to make it more difficult for a casual attacker. But somebody who's got full access to your machine, once they have access and you're logged in, well, that's not a good place to be.
Right. One thing Safe and the report said was that the attackers were very sophisticated. So they also deleted traces of what they had done. And so I'm not sure if anybody will know at the end of the day exactly what happened. To your point on, there could have been many ways in which this token was used.
Yeah, and these attacks could be stored all in memory, and so there might not be any or very little persistent evidence of anything, and what's there they probably deleted. So yeah, it may be very, very hard to know.
Even the malicious JavaScript was like 2 minutes after the exploit, it was placed with the Gen 1, which is kind of crazy.
Yeah.
Very tight execution. Okay, cool. So I wanted to kind of move on to like a general question around, given this, should people use separate machines, like one for regular, one for high security use, or one for like low security use and one for regular use? I don't think it would have helped Bybit in this case, because whatever computer this guy was using, it would have been it would have received compromised JavaScript. So can you talk a little bit about that from your experience?
Yeah, sure. So yeah, in this case, it doesn't help the user on the receiving end, but it might have saved the developer from getting compromised had they used a different machine. And so I think this is generally good advice if you're doing anything. It depends on your risk tolerance, your situation, right? So if you are responsible for some high stakes code that involves a lot of money or something like that, you probably shouldn't be downloading random stuff on that computer. That doesn't sound like a good idea. So having this separation is something I'd recommend, especially if you're going to run, if you're experimenting with development and downloading random programs from the internet and running them on your computer, probably you shouldn't do your finances on that computer and use it for your typically if you work for a company, they give you a different computer for your work, right, versus your personal stuff, because they don't want anything on your personal computer infecting your work computer. So this is always a good idea. But it's not going to stop all attacks, because it's a way of reducing the attack surface.
Right. Cool. I think the same can be said for regular users. At least I feel like, because I don't really know what I'm doing, this guy knew what he was doing, or he got pwned, or she, I don't know, they got pwned. Like, even though what you're saying implies that the dev should be more careful, I feel like as a regular user, I
if you are, I would say if you are the person responsible for signing crypto transactions of large dollar amounts, you probably shouldn't do that on a computer that you run untrusted software, because you could have a similar situation where your computer is compromised, and I mean, effectively the same thing could happen where you're signing transactions that are not what you intended to do because some malware on your computer injected
on my
something.
computer. Okay.
Yeah. So I think anybody in this chain really ought to try as best as they can to protect their devices. And one way to do that is to just use dedicated devices for this type of thing. Okay,
cool. So you also have some hardware experience. I think my final kind of question for this section is, there's an assumption that hardware wallets are not hackable, or they're the one thing we should check along the entire supply chain of signing. Can you say more about that?